solve using a calculator. All right, we'll do that. So let's go to matrix, over to edit. This is a 3 by 4. We have -5, -2, 1, 2. We have 4, -1, -6, 2. And then we have -3, -1, 1, and 1. And then we'll quit out of that so it doesn't replace that last cell. We'll go to matrix, and we'll go to math. And we have RREF because it doesn't say how. So we'll pick the easiest one. Matrix A, press enter, and we get at the very last line, we get really it's 0z or 0x or 0y, either one. 0z equals 1. That can't happen, so we have no solution. When you have zeros, but that last one is not 0, no solution. All right, so let's do the next one. Edit A, 3, 4. We got 3, 5, -8, -3, 2, 5, -2, -7. Oh, yeah, that's weird. Oh, let's try again. -7. There we go. Then we have -1, -1, 4, 1. We can quit out of that after we get everything entered in. And then now I can just go second entry because I replaced A. So this command should work with the new A. And we get, oh yeah, no, that's not what I wanted. I must not have entered in some values correctly. Let's try it again. Edit 3, 4, let's see, 3, 5, -8. 2, 5, -2, -1, -1, 4. Something must be wrong here. -3. Oh, I didn't get -1 on the very last one. -1. I had the advantage of knowing what it was supposed to be. So we go second entry again. Did I not press enter? I still don't want that. -3, -7. All right. Well, third time hopefully is a charm. I want all zeros at the end. There we go. Finally, got it. Sorry about that. Infinite. But now with infinite, you need this little extra piece that you can't have any combination of numbers under the sun. You do have an infinite amount of choices for z in this case. So we could pick 1 for z if we wanted. But then on the second row, we have y plus 2z is equal to -3. So y is -3 minus 2z. So -3 minus 2z is what y has to be. Then the x plus 0 times -3 minus 2z, and I know that's going to be 0, minus 6z, whoops, ran out of room, is equal to 4. So with that being 0, that makes it pretty easy. So x equals 4 plus 6z. 4 plus 6z. So now you can choose anything you want for z, but then x and y is based upon that choice. So on the quiz, I will want to see both of these lines for infinite solutions. And infinite and infinity are not the same thing. It's infinite solutions. All right, how about get a little review here. The inequalities, graphing them. All of these are in slope-intercept form. That's kind of what we want. So we have a y-intercept of 3 and a slope of 1. So something like that. Solid dot because it's equal to. Then -4 is the y-intercept for the next one with a slope of -1. But we need dotted line. A lot to keep track of on these inequalities as far as solid and dotted and graphing and all that good stuff. Then the last one has a y-intercept of 7. We go down 1, 2, 3, 4, 5, and left 1, 1, 2, 3, 4, 5, and left 1. And then we make sure that is dotted as well. So we have this little triangle in the middle, and that could be the answer, but it's not in this case, because we have greater than, greater than, greater than. So we want greater than on the first line we drew. Greater than on the second one would be here. It would actually be in the triangle, which sometimes that's what we suspect, but not in this case. And then the last one, if it's so vertical that you can't tell which one is above and which is below, because greater than should be above on all of them. If you can't tell, you can always try 0, 0. And 0 is not greater than 7. So here's 0, 0. I do not want to include that for this line with a slope of -5. So I'll shade on the opposite side. So now we're looking for the region where all 3 arrows exist. And it is not inside that triangle. It is actually right here. So that's where the shading would belong. That's above, above, and above. Any questions on that? So it's actually an infinite area. All right, next. Write the matrix equation and solve using inverses. So we can write this as 4, 3, 2, 1 times xy. And you have to do this in a vertical fashion by just the nature of multiplying matrices. You go across and down. So those have to be vertical, and then -5, -3. So if we're going to call this A, we're going to call this B, maybe call this C, we're going to multiply both sides by A inverse. And so we have xy is equal to, let's see, I need the inverse of A. I need this over here. So that's going to be 1 over the determinant. The determinant is 4 minus 6. You know, we cross multiply, right? That's kind of what I call it. It's kind of that way, but that's not, technically that's not true. So we do the cross multiplication, and then we multiply that times, switch the main diagonal, the 1 and the 4 switch places, and the other diagonal, we take the opposite of those. So they become negative in this case. And then we have to multiply that times b, which is -5, -3. Now, I always save the fraction till the end. It just makes things a lot nicer usually. So we have 4 by 4, nope, it's 4 by 4. 2 by 2 times a 2 by 1, so we should get a 2 by 1. 2 rows, 1 column. So cross and down, -5 plus 9. And cross and down is 10 plus -12. Now that's equal to -1/2 times. We have 4 and -2, so we have -2, 1. Whoops, I wrote it as a fraction. I don't want that. I don't want a fraction. So we have -2, 1, and that's what the answer is supposed to be, -2, 1. Don't write that fraction part. I didn't mean to do that. I was in fraction mode. Write the matrix equation and solve using inverses. All right, so you write the matrix equation, 4, 3, -1, 2, 1, 1, 1, -1, 1. And then that's going to be times x, y, and z, and that's equal to 4, 4, and 4. Well, we call this A, we call this B. We want A inverse times both sides, so I really want A inverse times B. So we go matrix, we don't do inverses of 3 by 3s. It's a long, drawn-out process. 4, 3, -1, 2, 1, 1. Oh, why did it? I was doing that earlier. I don't know why it's popping out of there. Matrix, edit, 3 by 4. Let's try this again. 4, 3, -1. There we go. 2, 1, 1, 1. There you go. Oh. I don't know what that is. Because I need to make this a 3 by 3. Try this again. 2, 1, 1, 1, -1, 1. So it's a 3 by 3, not a 3 by 4. So we can get out of this now. Go back into matrix, and we're going to edit. Go down to B, 3 by 1, and from the last class, I already have the 4s all in there. So 3 by 1, all 4s. We can quit out of that. We go matrix. We need A inverse, and then times matrix. We got an arrow down to B, and then we should be able to get the answer right here. So we have to point 2, -1, 1. So we did it right. Linda's investing $20,000 by purchasing 3 bonds with expected annual returns of 10%, 8%, and 6%, investments with a higher expected return are often riskier than other investments. She wants an average annual return of 1340. So we say that, well, 10% of what we invest in X plus 8% of what we invest in Y plus 6% of what we invest in the third stock, we want that to be 1340 on average per year. She wants to invest 3 times as much money in the bond with 6% return than the other two combined. So we have X plus Y. Let's say we say that's equal to Z, but that's not true. Because Z is 3 times more than X plus Y, than those two combined. So this side over here is bigger. It's 3 times bigger. So how do we actually make them equal? We take 3 times the left side. Now they should be equal to each other. That's how I set up those equations. When it's a multiple of 1, I set them equal to each other and go, okay, how can I actually make them equal? Because they're not. Well, if we want this equation in the same form as the first, we have 3x plus 3y minus z equals 0. So now the first and second equations are similar in nature. So I can plug them into a matrix. And finally, I think the third equation might be the toughest. Remember, x, y, and z is how much we are investing. So the third one is x plus y plus z is equal to the 20,000. That's so we can get the 20,000 involved and we can get that third equation. So now it just says we just got to answer the question. And if it doesn't tell you how, we're going to use that RREF, reduced row echelon form. So we have 0.1, 0.08, 0.06, and that's 1340. Then we have 3, 3, negative 1, 0, and then 1, 1, 1, 20,000. Enter. So we can quit out of there. We can go math, matrix math. Go B, and then matrix A. Press enter. Oh, wow. I'm not having much luck entering these values in. Oh, it's 0.08. 0.08, not 0.8. I can go entry, press enter. Oh, great. I did. 0.1, 0.08, third time again. Did I get this time? All right, here we go. Survey says, oh yeah, got it. So we got to label it somehow. So 10% is 2,000, 8% is 3,000, and 6% is that 15,000. There we go. So if we combine these two right here, 2,000, 3,000, that's 5,000. So yep, we invested 3 times more than that in the 6%. So it all worked out. How about another one where we do the determinant of a 3 by 3? I want you to do this by minors. So I just need the plus, minus, plus for that first row. I don't have to list all 9 out. That's not necessary. I just need that first row. It always starts out with a plus. So we have the plus goes with the negative 1. Remember, you have some extra signs. So minus 1 times, we're going to have these 4 right here when we cross out the row and column. So 0 minus 2 when we cross multiply. And then the negative goes with the 2. So it's not going to be plus 2. It's going to be minus 2 times. And then we have 0 minus negative 8. And then this plus will go with the 1. And then we'll have these 4 right here. So that's going to be minus plus 1 times negative 2 minus negative 12. So we have 2, that'll be minus 16, and it should be plus 10, right? Because negative 2 plus 12 is 10. So negative 14 plus 10, and it actually is negative 4. That is the answer. Any questions? All right, last one. And I said on the website I'm going to use 22 as an example. And what you could do, and where this is coming from, is you could say, well, this is a 2 by 2, and this is a 2 by 2. So the result should be, the result of multiplying this would be a 2 by 2. So what we could do, what the book has you do, and I actually don't want you to do this, you have negative 2x1 plus x2 should equal. So across and down on a 2 by 2 would give you the very first spot right here, 1, 1. Well, that should be equal to 4. And then you're going to go across and down on this one, which would be negative 2y1 plus y2. That gives you this spot, and 0 is in this spot, so that'd be 0. Now, we wouldn't put this in a matrix. We'd have this system of equations going on here. So there's 2 of them. And then the other 2 equations would be 3x1 minus x2 is equal to this spot right here, negative 2. And then, that'd be 0. Oh, no, right there. 3y1 minus y2 is equal to 3. So you'd have 4 equations, 4 variables you could solve for the system of equations. However, here's how I'd like you to do it. I want to use matrices. So we have A inverse times B. So we have 1 over 2 minus 3, so negative 1 times negative 1, negative 2, negative 1, negative 3. Switch these and make those opposite when you do inverses. Times 4, 0, negative 2, 3. Now we save the fraction. Well, this isn't really a fraction, but negative. Let's go with negative 4 plus 2 is negative 2. 0 minus 3, that's negative 3. Negative 12 plus 4, that's negative 8. And finally, 0 plus negative 6, that's negative 6. So we get 2, 3, 8, 6. But we need to answer the question. Now these are in the same spots, right? So x1 must be 2. X2 must be 8. Y1 has to be 3. And Y2 has to be 6. So that's what I will look for an answer.